Bismillahirrahmanirrahim. Today we will discuss about epilepsy and anti-epileptic drugs. So, what is epilepsy? Epilepsy is a seizure disorder. It is a disease which is characterized by seizure. So what are seizures, or what is a seizure? Seizure is a period when cell in the brain that is neurons are synchronously active at the same time when they are not supposed to. Now let us draw a diagram of brain. Let us suppose these are the brain cell. It is neurons. Let us suppose this is a glutaminergic or glutamate releasing neuron or a excitatory neuron, and let us suppose this is an inhibitory neurons. We will discuss about these excitatory and inhibitory neurons in detail in the coming lectures. This is another motor neuron which is attached to further neuron in the central nervous system. These seizure, how they occur in the brain, we will see here in this diagram. These are the electrical signals they are in this direction. Now let us suppose this excitatory neuron, this is glutamate releasing neuron. It releases glutamate. Here it will attach to NMDA receptor. All these receptors will be discussed later on in detail. Just here you look at the larger diagram, and let us suppose this receptor, this is releasing GABA. This GABA has a receptor over there, and this glutamate has a receptor over there. This is the excitatory neurotransmitter, so it will cause calcium, and this is the inhibitory neurotransmitter, so this will cause cause chloride ion in. Let us draw here another larger diagram. This may be drawn over here in a larger diagram. For example, this is the glutamate releasing neuron when an action potential come here, it causes the sodium ion which are in higher concentration outside to come inside this brain cell in the neuron. When the sodium concentration inside the neuron is increased, it causes the voltage gated calcium channel to open, so calcium ion come inside the neuron which are in higher concentration outside. This calcium ion causes the release of neurotransmitter. How the neurotransmitter glutamate is released by this calcium ion? What is the magic part of this story? For example, this is the glutamate vesicle, in which the glutamate molecule or glutamic acid molecule, they are stored on this vesicle. At its surface, it has molecule called synaptobrevine. We are here at the surface of the neuronal ending. There are molecule or there are receptors type which are called syntaxine. They have their ending closed, but when calcium ion come and it is attached over here, as we know that both the positive charges will repel each other, and this channel will be, and this receptor will be open. So here this vesicle will fit over there, with that synaptobrevine molecule, and this vesicle will be fused and it will release here glutamate molecule. These glutamate molecule, they will be acting on this next neuronal cell, this neuron has two type of receptor for this glutamate molecule. One is called NMDA receptor or N-methyl D-aspartate receptor, and the other one is called AMPA receptor, AMPA channel. N-methyl D-aspartate channel. It is having a receptor here for glutamate, and it is here having a receptor here for glutamate. When glutamate will bind over here, it will first cause sodium ions to come in. When the voltage inside this neuron is increased by the positive cation sodium ion, this channel is blocked by, normally this channel is blocked by magnesium. Magnesium is also positively charged, so this magnesium will move there. This channel will be open, and this will allow calcium ion to come in. Both these positive cation increases the positivity inside the neuronal cell. When this positivity reaches to the threshold frequency, then action potential is generated. This is called NMDA receptor, because instead of GABA, instead of glutamate, this is also a receptor for N-methyl D-aspartate molecules. Now what happens with the inhibitory neuron? This was this excitatory neuron. What is the story of inhibitory neuron? We will draw here another neuron over here. Let us draw here another neuron. This is the inhibitory neuron, and this is also sodium channels. For example, an action potential comes here. It will cause the sodium ion to come in. When the sodium ion will come in, the positivity inside the neuronal cell will cause the voltage gated calcium channel to open, so the calcium ion will also come in. Again, by the same mechanism, they will release the GABA from their vesicle. When GABA is released over here, it will attach itself to the GABA channel receptors. GABA receptor is a pentameric receptor, like a channel like this. It has a receptor for GABA or gamma amino butyric acid. When the gamma amino butyric acid will bind over here, it will cause the opening of this channel, and when this channel is open, it will throw chloride ion inside this neuron, so this neuron will be hyperpolarized. Can be shown over here. This neuron will be hyperpolarized, and it will not be activated by the glutamate or any other excitatory neurotransmitter. For example, this is the resting membrane potential of the cell. Let us suppose this is my minus 70 millivolt. Yeah, this is the threshold at which the cell may be activated. This is minus 50 millivolt. Threshold potential is the potential at which cell may be activated to cause the electrical impulse in forward direction. When this chloride ion is loaded inside this neuron, and this minus 70 millivolt, there will be negativity inside the neuron, a neuronal cell, and this minus 70 millivolt may reach to minus 90 millivolt. So when action potential comes, sodium ion will move inside. It will just be able to cause the negativity to minus 70 millivolt. It will never be able to move to this threshold voltage at which the cell is activated. So the cell will be hyperpolarized and will be never activated. So the GABA is inhibitory neurotransmitter in this way. Here we can draw another larger diagram for GABA. How GABA actually, this GABA A receptor, how it is actually made. It is a pentameric channel. Like this. This is the beta 2 subunit, this is the alpha 1 subunit, this is the gamma subunit, this is the beta 2 subunit, this is the alpha 1 subunit. This is a channel made like this. So there are different binding sites at this channel. This is the GABA binding site. When GABA is bound over there, it causes the opening of this channel, so chloride ion is loaded inside the neuronal cell. This is the benzodiazepine binding site. I will make rather it in benzodiazepine binding site. This also causes the opening of this channel, and this is the barbiturate binding sites. The barbiturates, the T described that barbiturate increase the time of opening of this channel, while benzodiazepine increase the frequency of opening closing of this channel. So when this glutamate receptor is secreted in a larger proportion and this GABA is secreted in smaller proportion, there will be sudden excitatory signal, they start over and over, mean repeated. This is also called paroxysmal seizures. This is also called paroxysmal seizure. Whether the neurotransmitter they are excitatory or whether they are inhibitory, this whole process occur naturally. There is excitation and there is also inhibition, but if this system is disturbed and there is increased secretion of these excitatory neurotransmitter, or there is a decreased secretion of these inhibitory neurotransmitter, they will give rise to this condition which is called epilepsy, and there will be abnormal repeated high frequency impulses coming from brain to different parts, and to which part they will move, they will affect the muscle of these areas, which we will discuss later on, that how they act on the muscles present in different parts of the body and how they give rise to epilepsy. Now we discuss about the causes of epilepsy. What are the causes of epilepsy? There are different causes of epilepsy. The most important cause of epilepsy is genetic factor. Genetic factor is involved in the epilepsy. Second cause is a tumor in the brain. The most dangerous situation. Third case is the brain injury. Fourth cause may be the infection in the brain.